Okay, so finishing the lesson from last class, we started going over some of the basic geometric shapes as far as the areas are concerned. We did the first couple of problems, so use your areas to be able to follow along with the rest of these. So the next problem, again, hopefully you guys recognize that as a triangle. Remember that the area of a triangle is 1/2 the base times the height being multiplied together. So in this case, this is your base. Okay, 14 is your base. And the height, remember, has to go from the top straight down or perpendicular to the base. So the height is going to be 15. So the area of this is going to be 1/2 of 14 times 15, which works out to be 105. And there's no units on this one like we had last time, but if there were, remember, because it's an area, it would be whatever the unit is. So we'll just say units because we don't know what it is, squared, because it's an area. All right, and obviously you can plug that stuff into your calculators and get those values. Next one, I do know that there is something missing here because I didn't give you any information. So we're going to go ahead and write that in ourselves. We are going to state, first of all, we're going to state that that is a diameter. So we're going to put a center right there so that we know that that actually does go right through the middle. We are going to state that this distance right here is 12, which tells us that the diameter is 12. Okay, so the area of a circle, if we remember from looking at our notes, is pi times the radius squared. Well, that means we need the radius. I gave you the diameter, but you should remember that the radius is half of the diameter. So our radius here is actually 6. So the area is going to be pi times 6 squared. 6 squared is 36. So remember that you can actually get an exact area and then a decimal approximation. The exact area is going to be 36, and then we literally just kind of tack on the pi as a multiplier. And again, it would be some kind of a unit squared. Now, if we wanted to do a decimal approximation for that, then you're just going to plug 36 times pi into your calculator and then see what that gives us. So 36 times pi is going to be approximately 113.097, again, units squared. Okay, so the first one is exact. Oops, if I could spell it right. And the second one is approximate. Okay, the next one. Hopefully we recognize this one to be a trapezoid, because remember, a trapezoid has two parallel sides. That side and that side are parallel. The other two sides are not parallel. The area of a trapezoid, again, looking at your formulas, 1/2 the sum of the two bases times the height. So the two bases, this is going to be base 1, that's going to be base 2. The height has to go straight in between the two bases, creating a perpendicular between the two bases. And that one is going to be the 4. That's your height. Again, basically straight down from the ceiling to the floor, if you think about it that way. So your area is going to be 1/2. We'll add the two bases, so 5 plus 8 times the height, 4. Excuse me. So you should always do what's inside the parentheses first. That is an order of operations thing. So 5 plus 8 is 13 times 4. And it really doesn't matter if you multiply the 1/2 times the 13 and then times the 4, or the 1/2 times the 4 and then times the 13. The multiplication can be done in any order. So either way you do it, if you do 1/2 times 13 times 4, you should get 26. And then once again, the units here, now they do give us units, are meters squared. Okay, Okay, and that's the area of our trapezoid. Number 8. We have another trapezoid because, again, I have a parallel side here, right on top and bottom. The other two sides are not parallel. And then the height is going to go, so here's base 1, base 2. The height is going to be perpendicular or straight down from both of the sides. There is the height. So we're going to do the area equals 1/2 the sum of the bases, which is 10 plus 24 times the height, which is 7. So let's simplify. 1/2, 10 plus 24 is 34 times 7. 1/2 times 34 times 7 is going to be 119. And it does not appear there are units on this, so we will just write units squared. All right, so that's the basics. Now we have something a little bit different. We still want to do the same thing, but now we've got algebra involved. We've got x's involved in this thing. So we have a parallelogram here. Again, parallelogram, opposite sides are going to be parallel. I'm not going to mark them in this case, but they are. The area of a parallelogram is simply the base times the height. But they give us some different information here. They actually tell us what the area is. They tell us the area is 252. What they want us to find is the value of x. Well, it looks like the base here is 7x. It looks like our height, because that goes straight up and down, is x. And the area, we already said, is 252. So we're going to plug all those things into our equation here. Area is 252. The base is 7x. And the height is x. So now we have a way to solve for x. So 7x times x is 7x squared. 252 is still just 252. If I want to now solve this for x, we have to get the x by itself. So let's divide both sides by what's attached to the x, which is the 7. So we'll have to do 252 divided by 7 and figure out that that is 36. And all you have left over here, the 7's cancel out, and you have x squared. So then to solve for x, because I have x squared, we take the square root. And the square root of 36 is 6. We have solved that one for x. Okay, moving on, we got a couple left. Excuse me again. Given that the area of the trapezoid is 300 millimeters squared, so they told us the area, find B1. We want to find base 1. That's the one at the bottom. They told us base 2. That's up here. They told us the height. That's the one right there. And they also gave us that 6 millimeters thing on the right-hand side. It actually has nothing to do with this particular problem. It's what's called a distractor. It just means that there's information that we don't actually need. But what we do need is the equation for a trapezoid's area, which is 1/2 the sum of the bases, B1 plus B2, times the height. So let's fill in what we know. We know the area. They gave us the area. That's 300. That goes right here. Okay, 1/2 is still 1/2. Base 1, that's the one we don't know, so we just write B1. Base 2, looks like it is 10. And the height is 8. So now we have to solve for base 1. Well, remember that I said you can multiply in any order. So I can't really combine what's inside the parentheses because one of those numbers is unknown. But I can multiply this 1/2 times this 8. So 1/2 times 8, or 1/2 of 8, is 4. Keep the b1 plus 10 in parentheses. Now, there are multiple ways we could do this. We could distribute the 4, which is perfectly fine to do, or I could divide both sides by 4, canceling out those two 4s, and then you'll do 300 divided by 4, which in your calculator works out to be 75. Then all I'm left with is that b1 plus 10 in parentheses. Well, since that's the only thing left, we can drop the parentheses. We have b1 plus 10. Then to solve for b1, we're going to simply subtract 10 on both sides of the equal sign, and we get that b1 is 65. So we've solved for the missing base in a problem where they gave us everything else, including the area. Okay, one more problem. Once again, they are giving us the area. Given the area of the parallelogram is 4,000. Try that again. 4,000 centimeters squared. Find the x. This is very similar to the one we just did a couple of problems ago. Area of a parallelogram, once again, is just base times height. Here's your base. Here's your height. The area is 4,000. We put 4,000 where the A is. The base is 10x. The height is x. Multiplying 10x times x, we get 10x squared. 4,000 stays on the left-hand side of the equation. We need to isolate or get the x by itself, so we're going to divide both sides by 10. Those 10s cancel out. Dividing 4,000 by 10 gives us 400. Oops, forgot my squared. And then we have to take the square root on both sides to solve for x. So x is going to be the square root of 400, which works out to be, in your calculator, 20. And we have solved for x. All right, that should be very helpful with what we're doing from here on out.